And yep, that's still there. Hello. Yep, still there. What happened to the picture? Weird. Stream manager. There you go. Okay, let me see. Yep. Yep. Oh. SQL.net. Do that. Hello. Hello, everyone. Hello. Hello. We're almost a minute in. Well, almost a minute in the session. We got 4 viewers on. Hello. Hello. Okay, anyone chime in? Share 1 bit for. I don't even know what that is. Okay. Anyone chiming in? Need someone in the chat. Anyone in chat? Anyone? Anyone? Someone chime in. Someone write something in the chat. 429. Yeah, I'm not seeing a thing. Hello? 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 Anyone? Someone chime in. Can anyone chime in? No, I'm seeing no chat. No one. Emote chat. Yep. Anyone here? Someone chime in. We got viewers. Anyone? And I can't even write anything. You cannot share on your own channel. What does that mean? What's going on? See all activity. Can anyone chime in? Can there someone write something in chat? I don't know what happened here. Not being able to see anything. Someone, can someone chime in? Someone write something in the chat. We only got like 4 viewers here. We are streaming, right? Stop streaming. All right. I need someone to chime in. You know the drill. This is so annoying. I'm not seeing any messages here. I'm not being able to see any messages. Can someone write something on our channel? Anyone? Share 1 bit for you. Yep, that should be working. Okay, so this is weird. Yes, here, okay. Oh, I see what's going on here. I think it's lagging. No, it's not lagging. It's the new Discord app is actually not the Discord app. The Twitch app is completely bugged. It's completely bugged right now. Okay, the mic is good. Okay, audio's good. I can't see any. Yeah, all right. Audio, hey, Do you stream off Twitch app on the OBS? Yeah, I stream off of, okay, DD band. Yes, I stream off of the OBS. Yeah, I do. The problem is that the chat is completely blocked off here for some ungodly reason. Hold on, let me come back in to the stupid app. This is the reason why. Okay, someone chime in. This is so annoying right now because I see that people are chiming in. Hold on, let me. Oh. This is why I hate system updates. This is why I hate app updates because, you know, when they do updates to apps, they're gonna screw it up. And certainly Twitch really, really screwed this one up. So fucking annoying. Keyboard settings. Hold on. Show the keyboard. Hold on. Sorry, we're gonna have a little delay here. I'm gonna actually go to the actual web app. Because, no, this is not okay. Video producer. Okay. Stream manager. Okay, got it. Alright. Hey, Rose Phoenix. Yeah, okay, so now I see it. Hold up. Let me type a hello message here. Show the keyboard. Hello. Can you see this now? Yep, you can see it. Alright. Yeah, we're good. Alright, mic check, audio check, video check. I think we're good. Yeah, we're good. Howdy. Hey, Mystery Flower. Okay, now I can see it. Hey, Rose Phoenix, DD Band. I see you all here. Here, okay. Yep, alright, we're good. We're on a little bit delay here, but welcome, welcome, welcome. Chat, put the scroll. What do you mean to scroll? Yep. So, hello. I'm gonna move my mouse back. I'm coming back here. And yes, it is October's National Cybersecurity Awareness Month. Sorry for the 5-minute delay. Yes, welcome. It's a big day today. Very big day. And, hey, Lozzie, how are you? We have an invader. Why? Okay. So, what we're gonna do today, I want to give you a little bit of a motivation and a continuing point. Can you see? Okay. Go to, I'm going to send a URL here. Go to the damn vulnerable web application at 34.67.36.57/DVWA. And of course, you should see a login.php. The username is admin. The password is password, all lowercase. All right, got an admin, got a password. I want to do a very simple exercise and a review, which is a prelude to SQL injection and what we're going to cover today. So let's go to the cross-site scripting reflected. Let's go to the cross-site scripting stored. Cross-site scripting stored activity. So for those of you who do not know, the damn vulnerable web application is a deliberately vulnerable web application. It's damn vulnerable. Its main goal is to be a aid for security professionals to test their skills and tools in a legal environment, help out developers to better understand the processes of securing web application. So this week and next week, we're going to continue talking about web application security and to be an aid. Don't worry about the warning. It says do not upload it to your hosting provider, public underscore HTML folder or any internet facing servers. Let's not listen to that. I need a way to actually demonstrate and to teach you folks. So let's go to the cross-site scripting stored exercise. Does anyone actually, someone, come on, type something in. Like and I don't care. Type something in. Let me hit the refresh button. Anyone here? You can go. Like, go onto the damn vulnerable web application. This instance at 34.67.36.57 slash DVWA. No one's typing anything in. Come on. Someone type something in. Okay. Let's say hello. And let's say my name is Steve. Hello. Sign the guest book. Ah, there we go. Hey, Mystery Flow. Ah, okay. But the reason why I want to show you, we want to start here, is because there is a couple of very interesting things. Anyone? Any more messages? Resend. All right, hi. But did anyone notice something? Did anyone notice something about the name field? If I do A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, oh boy. A, B, C, D, E, F, G, H, I, J, K, L, M, N. There is a character limit on the name field. There is a character limit on the name field. So if I do a view page source here, and here it is. Yep, here it is. The name field is a text box. Size is 30 and the max length is 10. So there is a maximum number of characters for the name field. There is none for the message. Okay. Okay. Sign the guest book. Okay. Here we go. Yeah, there is a limited characters for the field name. Yes, that's absolutely true. There's also, of course, a cross-site scripting vulnerability here. And I'm actually surprised and a bit disappointed that no one did any evil, sinful business here. So what cross-site scripting is, instead of entering a legitimate name or legitimate text message, you would type in, instead of, let's say, Joe, you would use script, JavaScript code. Open script tag. Ooh, you can't do that in the name field for some reason because there is a character limit for the name, 10 characters only. But you can do it in message though. This is a test. I can do that, or I can do script. Now hold on. If I do script alert, I'm gonna say hacked by Kelly underscore AMI. And script. Watch what happened when I signed the guest book. Now you hit the refresh button on your end. Actually, the delay is much less on the web app version of Twitch, which is kind of nice. Okay, hit the OK. Hello, hello, hello. How you? But hit the refresh button again. If you hit the refresh button, tell me. Ooh, now I got deleted messages and stuff. I don't know who did that, but someone ruined this, but that's okay. All right. All I need to do is to reset the database. Okay. So, I want to stop there. Let's not play. We're going to come back to the damn vulnerable web application a little bit later. Because later we're going to be doing the SQL injection exercise here. So now, I want to talk about the oldest trick in the book. And probably one of the most deadliest, if not the most deadliest vulnerability. It's arguably not only the oldest trick in the book, but you can do quite a lot of damage. In fact, this is a technique and how so much data breaches still happen today. Before we talk about the SQL injection problem, let's make sure we have an understanding of what the structured query language is. Okay? The best tutorial I've ever seen on the structured query language is SQLZoo.net. I'm going to paste that here. There we go. By the way, can someone send something in chat to make so I can make sure that this is working? Okay. So let's go to the select basics. Someone actually write something in chat. I would really appreciate it to make sure that this thing is actually working. Hey, Mystery Flower. Okay, Mystery Flower just chimed in. This is great. Thanks. Good. Hey, Lozy. Thank you. Great. So, if you're not familiar about databases, that's okay. Don't worry. Don't worry too much. That's okay. But what I think of a database as, if you don't know anything about databases, is think of it as many different spreadsheets. Okay, and I'm sure most of you have worked with spreadsheets before. Okay, think of a database as a collection of many, many different spreadsheets. The one big difference when it comes to SQL-based databases is you got to be very specific on the data types of each and every column. Here's an example. Go to sqlzoo.net/wiki/select basics. The structured query language, is a way to query databases. That it also includes querying, inserting data, updating data, deleting data, creating databases, creating database tables, the list goes on. So here's a database table named world. And this database table world has 1, 2, 3, 4, 5 different columns. Okay? So here's the introduction of introducing the world table of countries. So here's the structure. Hey, Sam. Hey, Kyra. Here's the structure of what is called a select statement. A select statement is to query or to find data in a database table or tables, plural. Yes, you can actually select data from multiple tables using select statements. Now here is how a select statement looks like in SQL. It starts with the keyword select. Now, for nomenclature purposes, keywords in SQL are generally in all uppercase letters. This is what I'm going to do. Okay. However, when you type in SQL statements, you can use lowercase as well too. But by convention, in literature and in books, keywords in SQL are all in uppercase. So here is select fields from table. At the most simplest form is select fields from table. Now fields can be the different or columns, okay, separated by a comma from the table. So here, back to this example, we have a table called world. It has 1, 2, 3, 4, 5 columns: name, continent, area, population, and the GDP, the gross domestic product. Okay, so I'm going to do this wrong, so I'm going to do select name from the table name is called world. Submit to SQL, and you're going to get a list of all the countries in the world. But this is, of course, question number 1. It's not what it's asking. Okay? So the result is wrong. But I'm doing this to demonstrate to you, for those of you who do not know, the structure and syntax of what is called a SQL statement. Or in this case, a select statement. You can also select multiple columns or fields separated by a comma. So let's say I want the name and the population get all the names, get all the countries and with their corresponding population from the world table. If I hit the submit SQL, you're now going to see each and every country with their respective population. Good. You know that. Okay. Now, sometimes you may not know all the, maybe you want all the fields. Maybe you want name, continent, area, and population and GDP. You can just specify each and every column that you want and separate each by a comma, or you can just use what is called a wildcard. Select star. Select star from world. And this is just going to dump the entire table that is world. See above. Select star. This is again what we're looking for. Okay? You can also have conditionals as well too. The where clause, and this is what the question asks. This example uses a where clause to show the population of France. Note that, this is very important. Here's a very key point. Note that strings in SQL should be in single quotes. This is a very critical point, and hence this is also going to be the Achilles heel of the structured query language, SQL. So you have select star from world. You can have where the where is a keyword in SQL, where name equals Germany. And Germany is a string, has to be in single quotes. Now I'm going to hit the submit SQL, and you'll notice wrong answer, too many columns. Okay? Just looking for population. Okay, get the population from the world table where the country is, in this case, country is name, where name is Germany. Name equals Germany. There you go. That's the correct answer. So now you have a general feel for the structure and the syntax of a SQL statement. Okay? And in this case, this very specific case, we're only going to be working with select statements for the most part. Select is defined and query data. Okay? So, now we get a general feel for it. But this is where the problem lies when it comes to SQL. Note that strings should be in single quotes. And now let me come back here and illustrate the injection problem. Okay, I'm gonna create a database table called users. I'm gonna have three columns: ID, username, and password. And like in the past, I'm going to be using people that I know. Username is Batman, and the password is Bruce Wayne. Don't worry about today. Don't worry that the password is not encrypted. Don't worry. Sam. And your password is going to be 432432. Okay. Sam, you're still there? Okay, hopefully Sam is still there. Alright, yes, good. Yeah, it's going to be good because we're going to need a few post checks today because the Twitch app is complete garbage. Okay. Mystery_flower, your password is I believe that we will win. Okay. Let's not get to that, Mystery Flower. Let's not get to that. Sam, I know your password because we're a genius. Who else we're going to do? I'm going to say Rose Phoenix. And your pass, we're going to make something up. Okay, so mystery underscore flower. Yeah, let's not get to that. Let's not do that. Let's not do that just yet. Let's not do that. One, as we'll see, it's a good question. We'll come back to it though. We'll come back. Rose Phoenix. Uh, we'll just give you this password. WTF Twitch. Come on. Now, let $username. Let $username equals user input for username. Let $password equals user input for password. Then the query, okay. Hey Ronnie, how are you? Then you have the query result equals select star should we do select star? Yeah, why not? From users where username equals the user input username and password equals inside single quote password. Okay, so lines numbers 1 to 8. Pretend we have a database table called users here. Everything after this little dot dash dash line here, this is all code. Think of this as code. Okay, let $sign username equals the user input for username. Let $sign password equals the user input for the password. Then the result is going to be the result of select star from users, where username equals single quote the user input for the username, single quote, and password equals single quote the user input for the password, and single quote. All right, so let's do an example. Let's plug and chug now. Let username equals do, and the password equals doodoo. Make something up. All right, let's plug and chug. Definitely should input. Okay, hold up. We're gonna get to that, mystery flower. Let's do a plug and chug now. But the question is, mystery underscore flower, where shouldn't you actually, or where should you actually put the semicolon in the username or the password? Oh. All right. So now we have this SQL statement on line number 15. Select star from users where username equals single quote do, single quote, and password equals single quote do, single quote. So is this a legitimate SQL statement? Is there any syntax errors? No syntax errors. It shouldn't be any syntax errors. And it's a legitimate SQL statement. This is going to run. But let's evaluate this from left to right. All right, select star from users where username equals do. Do we have a username equals do? No. Do we have a password equals doo-doo? Any password with doo-doo? No. What is false and false? False. Okay. So we have no username equals do in the users table above. So this is false. And we have no password that is equal to doo-doo. So that's false as well. So this whole SQL statement, while it is syntactically correct, it's not going to return any results because there's no record in users with the username where the username is do and the password is doo-doo. Okay? So let's start all over. Let's do another one. Okay, let's do the username as mystery_flower. And the password is, I believe that we will win. Should match, right? Hopefully. Make sure. Yep. Matches. We have a match. That's very important. Those little things mean a lot. Okay, let $ username equals mystery_flower, which is user input. And let $ password equals, I believe that we will win. That's also user input. Now let's plug and chug. Replace $username with mystery_flower, all in lowercase. And replace $password with, I believe that we will win. All right. Select star from users where username equals single quote mystery_flower single quote and password equals single quote, I believe that we will win single quote. Is this a legitimate SQL statement and legitimate syntax? Both could, yes. Now let's do the evaluation from left to right. Is there a username equals mystery_flower? Is there a username mystery_flower in the table of users above? And the answer is, yep, right here. Right here. Yep, we got that. Now, is there a another record with a password equals I believe that we will win? Yep, that one. Right there. But do we have a record that actually has both username equals mystery_flower and the password I believe that we'll win? Yep, right here. Select star. Gonna return all the fields. So result will be that. So $ result will be the ID is 3. You're gonna return a record with ID is 3. The username is mystery_flower and the password is I believe that we'll win. Okay. So $ result is going to return one record. All right. So we're good. That's good. Now, let's do something a little bit different. Now, instead of a legitimate password, let's do this. Let's do user input as that. Okay. So we have the user, $ username, the user input for username is still going to be mystery_flower. That's fine. So let's do a plug and chug and replace $ username with mystery_flower. Okay. Now let's say $ password equals WTF is this question mark. Plug and chug, replace $ password with that user entry. There you go. So now we have line number 15. Do we have a legitimate SQL statement with a legitimate syntax? And the answer is yes to both. But of course at this time the biggest difference is where username equals mystery_flower. Do we have a record that is mystery_flower above in the users table? And the answer is yes. Do we have a password as WTF is this question mark? The answer is no. Do we have a record that has both username equals mystery_flower and the password as WTF is this question mark? And the answer is no, we don't. So result is going to return nothing. Empty. Nothing. No results. Okay? And now, let's actually address mystery flower's concern. Now, let's keep the $username as mystery_flower. But this time the password is going to be O'Neill with a single quote. Now let's do the plug and chug. Replace $username with mystery_flower. And replace $ password with O single quote Neil. So the question now is this. Do we have a legitimate SQL statement syntactically? The answer is, well, it's line number 15 now, the SQL statement on line number 15. Is that syntactically okay or not? And the answer should be nay. Absolutely nay. And the reason why it's nay is because we have a mismatch of single quotes. Select star from users where username equals single quote mystery underscore flower single quote. That's fine. And password equals single quote capital O single quote neo single quote. The problem is the SQL statement here is syntactically wrong. It's syntactically incorrect because there is a mismatch of single quotes. Now, back in the good old days, a lot of systems, a lot of web apps, when they'd encountered an error like this, a syntax error with a SQL statement, there would be an error message that would be outputted to the web page, which is a bad thing. First of all, it gives way too much information, namely, especially the structure of how data is stored on the backend database. But also, it gives away that, oh, if there is a syntax error with the SQL statement and it had to do with a mismatch of single quotes, maybe we can fully take advantage of this. Now, let's do this. This time around, I'm going to start all the way at the beginning. I'm going to have a username equal blah. Actually, I'll have a mystery Kyra. Let $ username equals Kyra. And the password equals now. And the password is, now we got to be very careful. We're going to fully take advantage of the fact that we know that single quotes are going to cause problems. But what happens if we use a single quotes and we can actually mess up the SQL statement to return more data than necessary? How about the password is a single, let's say, a single quote space or, which is, we'll just do that just for some, or is a reserved word in SQL, space, single quote 1, single quote equals single quote 1. No closing single quote. See that? So now let's do our normal plug and chug. Let $username equals, replace $username with Kyra. And replace $password with this mess that we just crafted. Alright, so replace the $password with this mess. Now what do we get? Now the question is the SQL statement on line number 15, is this legitimate or not? Syntactically and semantically. Select star from users where username equals single quote Kyra, single quote, and password equals single quote a single quote, or single quote 1 single quote equals single quote 1 closing single quote. The answer is this SQL statement now on line number 15 is syntactically correct. No syntax errors now. It's also semantically correct. Now, let's do an evaluation from left to right. Is there a username Kyra in the users table above? The answer is there is not. So where this part of the SQL statement is false. And their password equals A. Nope, no password equals A. None at all. Now the order of the logic for where is from left to right. Great question, mystery underscore flower. From left to right. Or single quote 1 single quote equals single quote 1 single quote. Well, the last time I checked, 1 is always equal to 1. So this is always true. So we have where false and false or true. So false and false is going to be false. But what is anything or true? Now, if you really dig this, so it really boils down to, if you want to rewrite this entire SQL statement, it really boils down to select star from users where username equals false and false, or true, which really boils down to, take that, false and false is always going to, anything, that's going to be false. Then you break this down further where username equals true, Boolean true. Oh, whoa. Yep. Actually, I don't need the username part. So it really boils down to false and false, or true, and then it boils down to false or true, where true. What's going to happen? Returns everything. All the records in the database table. Yep. So, this is the SQL injection problem. In really, really lay terms, why SQL injection is so freaking deadly is because you gain access to data, more data than you should have access to. And this is a technique how so many databases are dumped, why there's so many data breaches out there, and also how you can even bypass things like a login system on the web. Yeah. Let's talk about how ugly this SQL injection problem is. Yes, you can also do that as well, Kyra. You can also do exactly what Kyra just wrote. Let the username for the pass, let the user input for the password equal a single quote, and then semicolon, drop the entire database table of users. And also, if you're not familiar with SQL syntax, the dash means comment. Okay? So, let's have an understanding of how ugly the SQL injection problem is. Let's take a look at the OWASP top 10. The OWASP top 10, this is an overarching list, not perfect, of the top 10 most critical vulnerabilities and issues affecting web applications and web pages. And for decades, we're not talking about just for years, we're talking for decades, SQL injection has always been like number 1 or 2. In the 2020, the latest list, injection now covered both cross-site scripting and SQL injection. Cross-site scripting, CWE 89 is SQL injection. So, in the OWASP top 10, SQL injection belongs to the injection problem. What about in the OWASP and here we have the CWE 89. We took a look at CWE most dangerous software weaknesses before. The 2023 list, CWE top 25 most dangerous software weaknesses. SQL injection is number 3. Here it is, read CWE 89. It's the improper neutralization of special elements, characters, used in a SQL command. And the description is, the product constructs all or part of a SQL command using externally influenced input from an upstream component, user input. But it does not neutralize or incorrectly neutralize a special element, such as a single quote, that could modify the intended SQL command when it is sent to a downstream component. Yep, and you can also do that as well. Now, one of my favorite articles of all time is the history of SQL injection, the hack that will never go away. Over 15 years after it was first publicly disclosed, SQL injection is still the number 1 threat to website. FYI, the story is still over 5 years old. It was written in 2015. Wait a minute. I don't understand. You may actually be. Wait a minute. Remember, this article was written in November 20th, 2015 at 8 a.m. Want to give a shout out to Joseph Cox. But here, wait a minute. You just noticed that this is the 2023 CWE Top 25 Most Dangerous. This is 2023 Top 25 Most Dangerous Software Weaknesses. SQL injection is number 3. This has been 8 years late. Okay, so this list was created 8 years later after this article written. Are we still facing the same problem we have had for all this time? That's right. So now you're starting to get the pattern. There's a reason why, there's a running joke I like to tell a lot of friends in cybersecurity. There's a reason why we are still continuing to get really big business and continue to be really well fed. Yep, here it is. One of the hackers suspected of breaking a talk breach. Yeah. Okay, so the method of attack was SQL injection, or called SQLI, where hackers typically enter malicious commands into form on a website to churn out juicy bits of data. It has been used to steal the personal details of the World Health Organization employees, grab data from the Wall Street Journal, and hit the sites of federal agencies. It's the most easiest way to hack. So you may be wondering why in 2015, and you can replace 2015 with 2023, is SQL injection still leading to some of the biggest breaches all around? SQL injection was possibly first documented by our friend Rainforest Puppy. Yes, that's his hacker handle. And so, Rainforest Puppy found that typing certain commands would force the server to reveal information stored on it. People could possibly piggyback SQL commands. This is exactly the example that we wrote. Okay? Today, over 15 years later, after it first disclosed, SQLI repeatedly sits in the #1 spot of vulnerabilities in the OWASP Top 10 report, which is released every 3 years by the Open Web Application Security Project, OWASP, which I just showed. Here we are. Fun reading for each and every one of you here. So I'm going to say this once. I think this may be the first time I'll say it all this semester, which is I started my cybersecurity career and learning about security in the year 2004. So in 2004, when I was learning cybersecurity, the #1 and #2 security weaknesses that I was exposed to at that time were cross-site scripting and SQL injection. Here we are in the year 2023, okay, 19 years later. And what is the top vulnerability still? Cross-site scripting and SQL injection. So you have to ask yourself, we've been fighting the same battle for all these years. In fact, for me, it's been 2 decades. Why? What the fuck? Okay? Now, this time, I'm going to actually go back. Let's go back to the damn vulnerable web application. I'm going to reset the database this time. Username is admin, password is password. Why is preventing not as simple as checking it? And what is restricting it? Mystery_flower. Preventing SQL injection is, there are straightforward ways to prevent, oh my god. Alright, mystery_flower, if there is a way that I could award you, like, I still haven't figured out Twitch yet, believe it or not, that, I wish I could give you an award right now. And it's not because it's not profitable. Here's the thing. Preventing SQL injection is rather straightforward. The concept of preventing SQL injection is rather straightforward. It is input validation, and we'll see a little bit later, called using prepared statements. The problem is it's laziness and education. Because as you know, that a lot of software developers are generally pretty lazy. But the other one is this, and this is the root cause of a lot. I feel personally, this is the root cause of a lot of problems in cybersecurity still. Some of the really basic problems are just not even exposed to developers. Because if you take a look at the people who do software engineering, most have never taken a security course before. They have never ever been exposed to basic vulnerabilities like cross-site scripting and SQL injection. So those are your two reasons why. It's not necessarily because it's not profitable. Now it actually there is a case to be made that it's not profitable in the short run, but it is just deadly in the long run because of your reputation and legal matters. It is way easier to define what is allowed than what isn't. That's, yeah. And Kyra mentioned the other thing too, exactly. And you mentioned, I mean, most of you are all doing software, like in computer science, and you unfortunately have all been trained in a way that you build something according to a spec. Yeah, I mean, it's what Kyra said. It's way easier to define what is allowed than it is to define what isn't. And if you ever do, real software engineering, and even do things like Capstone, there is almost never an exercise to think about what could possibly go wrong. Funny that Kyra, you said that because when I ran senior Capstone for years, one of the exercises is not only a design exercise, but also think about what could possibly go wrong in the design phase. So Kyra has also nailed something spot on. Okay, so the mystery underscore flower, the solution is rather, it's very well known. It's just people are just friggin' lazy. All right, let's go to the SQL injection exercise. You do it. All right, hands on. Hands on. Dump the entire database here. Go for it. You do it. User ID A. No. B. All right. 1. Sure. 2. All right. 3. 9. All right. You get the idea. You should be able to dump the entire database onto the screen. Go for it. I want you to dump the entire database. Oh. Very important. Hint, hint, hint. View source. There's a view source button at the bottom of the page here. The view source button. Click on that. You get the source. Hint, 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 hint. Right there. Someone actually, I'm looking for someone in the chat to actually dump the entire database using this exercise. Go for it. I wonder who's going to win this race. Come on. All right, Rose Phoenix got it. You got it? What payload did you use for the user ID? What did you use for the user ID? I don't know if you can type it in, but I hope you can. Don't worry, I'm not going to ban you. Twitch is being dumb today. What's the payload? All right, I'm typing in what you wrote. Single quote space or. Again, it doesn't matter the case, whether it's uppercase or lowercase or space. Single quote 1, single quote equals single quote 1. No closing single quote. There you go. Well done. There you go. Dump the entire database. Who the hell was admin? Was that number 1? Oh yeah. Huh. Didn't know that. You can also do anything, single quote, space, 4, space, single quote, 1. Well, you can do single quote A, single quote equals single quote A. It doesn't matter. But no closing single quote at the end. Well done, FR. Hey, FR Doomer, how are you? Yeah, well done. Okay. So, okay. This is a SQL injection exercise. So now you know the SQL injection problem. You know the SQL injection problem, but now let's have some fun. And now let's dump a voter database. Let's do that. But I want you to remember, if you tuned in at the very beginning, remember hey you, nice. All right, that is excellent. So someone really messed up with this blog. Hey, Kyra, how are you? Whoever did this, great work. Great work. Remember this exercise here, the stored cross-site scripting exercise, and there was a character limit. There's a character limit here, 10 characters. There's a 10 character limit here. Okay. But now, I want to introduce to you to the deliberately vulnerable voter database. Okay. So if you go to http://34.67.36.57/voter.db. How did Kyra write off the cat? I think Kyra actually used HTML. It was just, yeah, hold on. Oh, hold on. Fuck. Let me reset the database. Yeah, so Lozzie. Why is it like possible ban evader? This is no, this is so annoying. So if you do cross-site scripting stored exercise, hey, I thought I deleted. Oh, I didn't delete the database. So do A, and I just do strong, or I can do like an H1 tag or something. Lolzy 8470. I hit the sign guest book. Someone actually had a pop-up hell. Oh. Yeah, you can do that. Okay, I put more than 10 characters in there. Okay. So, interestingly enough, Kyra, is that you actually alluded into our next conversation. The other way to actually bypass the authentication, bypass the character limits is, yeah, edit the max character limit and put HTML in. You can do that. But I'm going to show you another way. So you can do what Kyra did, but that's the El Cheapo way of doing things. I think you have a little more elaborate way. I don't want to ban anyone. Here. Here's a voter database we're going to dump. This is a simulation of a real voter database. This is a fake Find My Voter registration status. I'm sure you all have used one of these before if you ever voted. So here it is. To find your voter registration information, enter your name, your date of birth, your zip code at which you are qualified to vote. All fields are required. Okay. So I'm going to do the first name is Kyra Torvey. Date of birth month, let's say January 4th. And I think you're a 2000 person, I think. Zip code is going to be 02155. Check this box before you can view your. Okay, sure. Submit query. Got nothing. Got absolutely nothing. But like the damn vulnerable voter database stored exercise here. Hey, Sam. Uh-oh. Yeah, I'm betting this is a Rickroll. I'm betting money this is a Rickroll here. So like this vulnerability here in this cross-site scripting exercise, there is a character limit here for the name field. We know that, 10 characters. But we also have character limits and even more restraints here. Namely, date of birth month, pull downs. But look at the zip code. 5 characters max. Check this box. Yeah, no result. So, is there a way that you can bypass these character limits and restrictions on a web page or a website? And the answer is yes, there is. One way is to do exactly what Kyra did. Save the HTML onto your computer. You'll do something like File, Save Page As, save all like a web page complete or the HTML only, and save it on your desktop. You can do that. The one thing is you just have to find the form field and the constraint and then just remove it. So if you're not very comfortable with HTML or modifying HTML, that could be a pain in the ass. There is another way. Now, I want to ask each and every one of you before we continue on. Does anyone remember how the web works? Anyone remember how the web works? What kind of a protocol? Yes, it's client server protocol, but how does the web work? Okay, we have a get and post request, HTTP. Okay. It's like I should take a screenshot of this. Twitch is so annoying. It's like I have to ban Lozy. Why do I want to ban Lozy? 84. Why do I want to ban you? I don't want to ban you. I want to keep you on. So get and post request. You also have at mystery_flower says request response. No, you're not getting banned, but I'm getting a message that says possible ban evader from you. It's like, why? So dumb, Twitch, today. Okay. As mystery_flower says, is the HTTP request response. Here is, I am right now, this is my client software. I'm on a web browser, so I'm a client. The server is at 34.67.36.57. That's the server. So if you want to take a look at the diagram of how this, quote unquote, how this web works with the Find My Voter database, it works like this. That's me right here. The web server is at 34.67.36.57. Eventually, the server at 34.67.36.57 will do number crunching on the data that I entered in, and it will send me back a response. But what if I did this instead? Is it possible that we can have a way to intercept HTTP requests before it is sent to the server? We modify anything and anything that we want, all the data that we want, before it is sent to the server, and then the server uses that. Okay? So right now, this is a direct request response model. But what happens if we can have a tool or software that can intercept requests? And then you can do any modification that you want to the HTTP request, including like modifying input data and then sending it out to the server. That's okay. Don't worry about that. And what I want to introduce to you now is something called a web proxy. A web proxy, think of it as a middleman. A web proxy is a software that you run on your computer that is essentially a server that will intercept your HTTP request. Then you have the opportunity to modify any of the inputs to anything that you want, bypassing any restriction. Then you hit the return, and then you send it, and then that request gets sent to the web server by the proxy. Okay? So I want to introduce you to the idea of a web proxy. There are quite a few web proxies available, and a web proxy is a quote-unquote must tool, an important tool for anyone who's going to do web application security. There are things like OWASP Zap. OWASP is called a Z attack proxy. All right. It's not only just a proxy, but it also has a web application scanner. Zap is free and open source. Okay? Zap is free and open source. There's also Fiddler, which you have to pay for. But arguably the most popular web proxy in web application security It's called Burp Suite. And it is made by the folks at Portswigger. Burp Suite Application Security Testing Software. Burp Suite is two products. There's a free and there is also a commercial paid license annual. Okay, what do I want to do? I want to do hands-on web testing. Okay, that's like a pro. So I want to go to actually here. Let's go to, so now is either the Enterprise Edition, Professional, or the Community Edition. Burp Suite Community Edition. This is the one that you want to use, especially if you are a learner or a student, and it's wonderful. Burp has been used for so long. The reason why this is more popular, but Portswigger's Burp Suite is more widely used than that. It's the same functionality. The problem is Burp has been used for so long, so you have that network effect. So Burp, you can download Burp Suite for any operating system, Mac OS, Windows, Linux, okay, and it's free. The biggest difference between the Community Edition and the paying professional version is the professional version has the vulnerability scanner, automated vulnerability scanner, okay? Here it is, yada, yada, yada. Here's the difference. The Community Edition will have HTTP and HTTPS proxy and history. So yes, you can use Burp to actually build a map of a target or website that you are trying to audit. It has the intruder, a demo version, as essential tools like the repeater, decoder, okay. The professional one here has everything that is in Community Edition, plus a web vulnerability scanner. Interestingly enough, we did vulnerability scanning last week. We did not talk about Burp, but you could add Burp as a vulnerability scanner as well. Okay, so assuming that you have downloaded Burp, okay, which I did, let's do this. I'm going to go and look for Burp Suite. Burp Community Edition. Burp Suite, if you're curious, it was written in Java. It is written in Java. You're going to get the screen. Burp Suite Community Edition. Get the screen. Hit next. Configuration. Just hit next. Start Burp. There you go. Welcome to Burp. Welcome to Burp Community Edition. If you are actually on the Pro version, you can actually use Burp as a vulnerability scanner for scanning for SQL injection, vulnerabilities, operating OS command injection, which we did in class on Tuesday, and all these other very, very popular and well-known OWASP top 10 vulnerabilities here. But we want to focus on the proxy. Now, you can also go to the Target tab, and there's nothing on here. The sitemap, yes. Burp will actually build a nice sitemap of a website. Let's go to Proxy now. The Proxy tab. And what will be highlighted first will be the intercept. Interception is off. When enabled, requests sent by the Burp browser are held here so that you can analyze and modify them before forwarding them to the target server. Hey. What is really nice about the newer version and the latest versions of Burp, unlike in the past, Burp now actually has a built-in browser, Chromium, or Chrome without all the Google branding. So we're going to hit Open Browser. There it is. Look at that. Now you will get a very, very nice version of Chromium that is very specific to Burp Suite. Now let's go to the vulnerable voter database. HTTP 34.67. 36.57/VoterDB. There it is. Now, notice what's going to happen in the target. It built a sitemap of all the files for our app. You can see all the request response. Let's go back to the proxy. Now, I'm just going to enter some data in. A, B, February. Why not? Hit the submit. Now it's still doing a straight request response, like what we just did moments ago. But now watch what happens. Intercept is off. Now we're going to turn intercept on. Notice what will happen. Intercept is now on. Requests here sent by browser will be held here so that you can analyze and modify them before forwarding them to the target server. Let's do this all again. But notice what will happen when I hit the submit button this time. First name is A, last name is B, date of birth month is January 1, year 97, zip code is, let's use all 5 zeros. Click the checkbox. Watch what happens when I hit the submit button now. Now you notice there's a couple of things. The first and foremost is this little indicator. Notice that in my tab bar, it's working. It's waiting. The spinning circle. It's waiting. Nothing gets sent to the server at 34.67.36.57 yet. Because the request is now held up in Burp. Notice here you have the entire HTTP request header. This is why you need to know HTTP, the Hypertext Transfer Protocol. This is a full HTTP request. The stuff I just highlighted is the header. Notice that you have the HTTP post verb. You have the route. You have the host. You have the content type. You have the user agent. You have all the fields. You even have the request body. And in fact, take a look. You can modify anything here, any data that you want here. And in fact, what Burp also has in a pretty nice way, the request body parameters. You can modify any of these fields right from here if you want. There are 19 requests that you can even see. It breaks down all the request header fields, and you can modify any request header field that you want. You can also modify any request body parameter field that you want. This is really nice. Look at the request attributes. Method is post and the path. You can modify anything that you want. What we want to modify is this stuff right here. Namely, the zip code. Alright, I'm going to bring up the web browser here. Alright. And I'm actually going to, here you go. Yeah, that will work. So now what I'm going to do is I'm just going to do something stupid. Date of birth day is 32. I know that's ridiculous, but it doesn't exist. But I can do that if I want. Or 33. Date of birth year is, let's say, 1776. The zip code, let's do a typical SQL injection. 0, ampersand, 0, single quote, space, or space, single quote, 1, single quote, equals, single quote, 1. So the zip code I changed. Now, as you can see, the zip code is a lot longer than 5 characters. It's also a SQL injection payload. 0, single quote, space, or space, single quote, 1, single quote, equals, single quote, 1. No closing single quote. Now to send this now to the server at 34.67.36.57, Watch what happened. All you need to do is hit the forward button, forward the request. And when you hit the forward the request, watch what happens on the web browser. Bang. We just dumped the database. This is how you dump the fake Find My Voter registration database. There you go. I think there's over 10,000 records here. Yeah. There you go. Yeah. Dump the database. Again, web proxy is a must tool. Very important tool if you're doing web application security. Okay? How you dump the data. Come back here. Let's go back to the damn vulnerable web application. Let's go back. We can actually go back to the damn vulnerable web application and any request that I make, like even just doing my magic one finger salute, changing the URL, doing 34.67.36.57/DVWA and hit the enter key. Oh yeah, it catches all the requests that are sent. I can do an intercept on. I'm going to hit the forward. You can see it's a get request, a forward, keep forwarding. Now, you can also toggle the interception. Let's go back to intercept is off. Notice the target. Look at that. Look at the site map for DVWA. Oh yeah, you can see all the images and stuff here. That's built in. Oh yeah. You can do admin, password. Oh yeah, look at that. Builds you an entire site map for you. This is the one thing that is hard to, that burp, a tool like burp will do, that you can't do when you just do save the HTML to your desktop. Now let's go to the cross-site scripting. I don't know what damage was done on the cross-site scripting stored. Oh man. Alright, let's do a reset database this time. Reset the database just for the fun of it. Okay. Now let's go to cross-site scripting stored. Now this time I'm just gonna intercept chain toggle from off to on. Intercept is on. But now I'm just gonna type in A B C D E F G H I J K L M. Alright, that's it. That's the message. What happens when I hit the sign the guest book? Boom. Text name is H1 mystery underscore flower H1 message. Alright, fine. I'm gonna hit the forward, the request. Woo! There you go. Alright, I'm gonna do something now a little bit more sinister. Just do another one. This time I'm just gonna do the username being a lot long. This time I'm gonna make it a lot longer than 10 characters, which is going to be Lowsy8470. And the message here is not A, but not banned. And also, why not, I also put a script tag in the username and script tag alert hacked by Sam and script. So now the username is going to be all in bold characters Lowsy. Oh, but I'm also going to shove in a script here. Hacked by Sam, and the message is not banned. Forward the request. See what happened. Boom. There you go. Alright. One more thing. How do you prevent SQL injection? How do you prevent it? The real way you prevent SQL injection is, well, to sanitize input. But you also, these days, want to be using something called prepared statements. Okay? And I have a great post. How you prevent SQL injection statements, SQL injection, really it boils down to validate the input. But more importantly, do not mix data and code. Do not mix the two. What we have been doing this whole time has been mixing data and code together. You don't want to do that. Prepared statements eliminate that idea. The root of the SQL injection problem is the mixing of the the code and the data. In fact, a SQL query is a legitimate program, and we're creating a program that dynamically adds data, dynamically adding some data on the fly. We've seen this one already. There you go. Select statement where ID, where this code, where is $ spoiled underscore data, will produce a malicious sequence. I think it was Kyra that did the drop table one. Okay. Now, what a prepared statement is, look at any programming language, any web app framework, these days support prepared statements. There's no excuse for you to not use prepared statements. But how prepared statement works is this. First, you send a program to the server first. Like, you have a function called prepare, and then you feed in your SQL statement where any variables is replaced by a question mark, better known as like a placeholder. Okay? Note that exactly the same query is sent to the server without any data to it. So you first send the query first, but then the second thing that you do is you send the data. And then we're actually sending the data with a second request, essentially separating from the query itself. DB execute $data. So even if you type in data with a single quote, a question mark, or whatever special character it is, it won't affect the SQL statement and the operation of the statement. So it can't alter our program. Okay, so you separate the data and you separate the program out. And this is like the best way to prevent SQL injection. But how many people do this? Well, more now, but you still have way too many people who just do things like concatenating data and SQL statements together. Bad. All right, folks, we're done. Even with all that bad start, yeah, we only went over by 4 minutes. Yep. So next week, more web security, or lack thereof. A lot of facepalm next week. A lot of facepalm. Yeah. Thanks, all. Thanks, all. All right. I am done. See ya next week. Yeah.